Hello everyone, George here, and we're back again in my implementation of Five Nights at Freddy's. We are going to, in this video, hopefully do something kind of interesting, and that is add noise to our camera switching capabilities that we added in the last two videos. So to begin with, I have this kind of little sheet that I've written down. We're going to create some camera noise, or some general texture noise in Photoshop. We're going to put a camera somewhere in our scene, and then we're going to have the camera, when we do the switch from one camera to the next, switch to that in-between camera, which has noise in front of it. It's going to look at that for a short period of time, and then it will move to the other camera after, some amount of time. And in order to make the plane of noise continually change, we're just going to randomly move around the UVs inside of the texture region from 0 to 1, and then we'll see if that works out for us, okay? So let's go ahead. Oh yeah, we also need to generate some white noise inside of Adobe Audition. I'm running Audition right now to record this, so I might need to, I don't know how that's going to work. So I might not be able to do that on camera. We'll see. So let's go ahead, jump into things and see what's happening. So first up, Photoshop. So let's go ahead and do Photoshop. Let's go ahead and create a new file. Let's make this 2048 by 2048. Why not? Create, make it big. Now we are going to fill this with noise. I'm going to select black and white as my default colors. Let's go to Filter, Noise, and Add Noise. It's going to ask how much noise we want to add. I'm going to make a lot of noise. We're going to make it monochromatic. Let's do it based on Gaussian. So there we go. So there's our noise, looking nice and noisy. Now we don't have a lot of gray noise, which is kind of nice. But what I'm thinking more or less is that we're going to divide up the regions. You know what? I'm trying to think. Let's do a filter. If I blur this, what do I get? It's a little bit nicer, I guess. And you know what I think I want to do is, I don't want to do it this way. We're going to not do that. We're going to File, New, and I'm going to actually create something smaller and then blow it up. So let's do a 512 by a 512. And I'm going to add noise to that now. So let's see, render, noise, add noise. Okay, now the noise chunks are much larger. Now what I'm going to do is go to image, image size, and we're going to choose nearest neighbor for how we blow it up so that it keeps the hard edges. If you don't do that, it's going to smoothly interpolate, which is going to cause blending or blurring between different parts of the image. I'm going to make that 2048 now. And you can see now it's the same, but the pattern of the noise, if that, not that there's pattern in this noise, but the idea is that I've blown up the features of the noise to a much larger size. And then what we can do on top of that, if we wanted to, is create a new layer, go to Filter, render, let's see, noise, add noise. Because the selected area is empty, let's just fill it with something. Shift F5, enter, filter, render, noise, add noise. Now this is a smaller pattern compared to that big pattern right there. And if we wanted to play around with things, let's see what overlay does. Does it do anything interesting? I mean, it does create these smaller little sort of facets within the noise, but I'm not really seeing anything of benefit. So I think I'm going to get rid of that. Now, if we hit Control and apostrophe, we get the lines, the grid lines, but you can't see them very well because of the fact that this is black and white. So that's not helping us at all, is it? But anyway, now that we have our noise image, let me blur this ever so slightly. So Filter, Blur, I'm going to add a tiny bit of blurring, just a little bit. And we're going to save this off. And what I think we're going to do is, the idea is that we're going to be moving us all throughout the image. And if you move it fast enough, see how it kind of looks like it's animated noise, like on a television, if you're old enough to remember what that actually looks like before everything went digital. So hopefully, that's what we'll end up with. So let's go to File, Save As, let's see, reproduce at FNAF, PC, speed, YouTube. Let's do Photoshop, and I'm just going to call this noise or camera noise. File, Save As, and then I'm going to save this PNG. under my textures folder and just call that camera noise as well. That's fine. Yes, please. Let's go ahead and open up Unity right here. And we're going to want to make sure that's an asset that we're working with. Whoops, that was definitely not what I wanted to do. I have no idea what I just moved. I moved something somewhere that should not have been moved. Well, I'll deal with that later on, I suppose. Let's bring that object into our scene. Let's create a new folder. And I'm just going to call this camera noise, I suppose. Right-click, import new asset, Big Bane, speed, YouTube, and textures, or reproduce it, FNAF, then textures, and we're going to go with camera noise. That gets added in, so that works for us. We don't need to worry about the anisotropic level. All the rest of the stuff should be fine. We might want to not allow it to resize, just to keep things hard-edged. Instead of repeat, yeah, we'll actually do repeat. That's fine. It won't matter for what we're doing anyway. But now we're going to create our new camera and put it off somewhere. So under our camera manager, we had all the current cameras in our scene. So I'm going to do a new game object. Let's just create a camera. I'm just going to push this up somewhere high in the world. And there it is right there. I'm going to put it under this as a child. And I'm going to call this camera underscore noise. And our camera manager is handling all this. So we're going to create a new element, not one of these elements, mind you, that we have here in an array, but instead we're going to create one that is instead just specifically for the noise. Sorry if I sound a little bit growly. I still haven't regained my voice from being sick. So let's do up here, I'm going to do public camera noise, or camera noise, something like that, camera noise. And that should be all we need for that. So there's our camera noise, our clear flags. I'm going to just do solid color. I'm going to make that black, so I don't have to worry about anything being rendered behind it. Not that it will really matter. The far plane doesn't need to be far out there. Near plane, let's shorten that to like 0.1. So our frustum is really, actually our frustum can be a lot smaller. Let's just pull that way in somewhere like that. So it will only be our noise plane that ends up getting rendered. We don't have to worry about any other ones getting in there and messing things up. Now I do need to create a plane for it. So I'm going to go in here. Let's just create a, let's see, game object, 3D object, a plane. Rotate this 90 degrees. Now actually, now this plane itself, I don't know what the UVs are set up like. If we go over to wireframe, you can see there's a lot of UVs on this object, which is not something I really necessarily want. So why don't we just create our own mesh that we're going to work with? And inside of here, create our own script. So C# script, and let's call this camera noise. And inside of here, we're going to attach this to a blank game object. So let's go game object, create empty, right there. I'm going to grab it, move it somewhere. I'm going to attach this to the camera, make it a child for right now. So there we are. So it's under that object. I'm going to zero it out so I'm right where the camera is actually at. And then now I'm going to make sure this is local. I'm going to pull this out a bit and just make sure that the camera is also facing in that direction. Great. So now that I have that set up, what we can do is actually have this thing auto-generate the mesh renderer, the mesh filter, and so forth, and then create a plane that we can then manipulate ourselves. So let's do, mesh. We're going to add two objects to this, right? We're going to add a mesh renderer and a mesh filter. So let's do this dot game object dot add component and mesh renderer. And then we'll do this dot game object dot add component, and we'll do a mesh filter. We're going to save them out for a moment here. Let's do mesh renderer, temp R is equal to this, and then mesh filter, temp F is equal to this. And there we go. Now we need to create an actual mesh. We're going to do mesh, temp mesh is equal to this. It actually is just a new mesh. Now we need to add the vertices to this thing. So the vertices for it are just going to be 0, 0, 1, 0, or actually, we should probably make it negative 0.5, 0.5 instead, so that it's kind of centered around 0. So let's do temp mesh dot add temp mesh dot vertices is equal to, we need to create that list. So let's make that list of 4. So we'll do what? A vector 3 array of size. So we'll do a vector 3 array and call these vertices. It's equal to new vector 3, and it's going to be of size 4 for what we're handling. And let's see here really quick. Oh, there we go. And then we can just do vertices 1, 2, and 3, and so forth is equal to, and hard code it, new vector 3. There we are. And we're going to do vectors 1, 2, and 3, and 4. Or vertices 1, 2, 3, and 4, which we're going to go all the way around it. And if I remember correctly, this is left-hand positive or DirectX format, which means we're going to want to do this in a clockwise method instead of counterclockwise, which is what OpenGL does. So clockwise. So we're going to start with, I guess, negative 0.5f. We're going to be negative 0.5f in the y, and then 0.0f in the z. We're not going to have any direction in the z whatsoever. Now all we need to do is copy and paste this a few times, and we're just going to change the signs. So we're going to go from, I'm just going to use this as an example here. Let's grab a different color. So if, where's my mouse? I can't even see where my mouse is. This to this to this to this, something like that. This down here is where we're starting. This is the origin right around here. So it's 0.5 in the negative x, and then negative 0.5 in the y, and then we're going to move to this vertex, and then this vertex to finalize everything. And we're going to use triangles to do this, and actually, or quads. We'll do a quad. We'll let the computer itself cut that in half for us. It doesn't matter. So if we're going to the next one, we're going to be positive in the y-axis, negative still there. Then we're going to be positive and positive. And then we're going to be negative and positive. And those are all the points we need to worry about. Now we also need to come up with our UVs. So let's do a vector 2, because we're dealing with two-dimensional coordinates, and just call this UVs is equal to a new vector 2, and make that, we need a UV for each of those, so it's going to be size 4. Let's just do this down here. So UVs 0 is going to be equal to a new vector 2, and now we just need to fill it in. And these values are going to be between 0 and 1. They don't have to be because we wrap things, and that means that it'll continue to wrap the texture around it, but it's fine. Now, what scale do we want to be working on to begin with? That's a good question. We can transform. So we could just, let's just start with 0 to 1. So this is the first vertex, so that's going to be associated with this first vertex, and then the next one with this one, and then this one with that one, and then so on and so forth. So the first one is in the lower left-hand corner, so that's 0, 0. The lower right-hand corner is 0, 1, or excuse me, 1, 0, and then it's 1, 1, and then finally 0, 1 up there. So let's go and make that happen. So 0.0f, 0.0f, and then we're going to go to 1.0f, and then 0.0f in the y, and then 1.0f, 1.0f, And then finally, 0.0f and 1.0f. And we have all that working for us. Okay, so we've got our mesh vertices, and we have our mesh UVs. We also want a normal probably for this. So we can do our vector normals, vector 3 normals is going to be equal to new, vector 3, size 4. And we're going to want normals for each of our vertices, and they're going to all be the same. They're going to be pointing straight out of it. And let's see, vertices, normals, we don't need colors. We need indices. We do need indices, and that's going to be an integer array. Call this indices is equal to new and int array of size. Let's see, we're going to have how many indices? We need to have an index for, we're going to say it's, let's choose a different color. So index 0, index 1, index 2, and index 3 for our quad. Great, so that's going to be of size 4 as well. Actually, you know what? Let's just get rid of the normals for the moment. I don't even know if I'm going to support lighting on this thing. We'll come back to that if we need it. So indices, and then we'll do 0 is equal to, and then that'll just be 0 because it's, so this index is saying, please use vertex 0 and UV 0 to do this. You do not get to specify in the index different vertex and UV sets. They're paired up, they're matched. That's why you have to have, for every vertex, you also have to have a associated UV. So let's do this a few more times. And then it's going to be really easy for this. It's going to be 1, 2, 3, 1, 2, 3, I believe. Watch, I'll screw something up, but it's fine. And then now we just need to associate these things. So we're going to do dot vertices, dot UVs, and then we're going to do dot indices, or dot set indices. And we pass in our array, the type, and the mesh. Yep. Okay, so the first one, vertices, is just going to be vertices. The next one is going to be our UVs, which is just UVs. And our final one takes a little bit more work. Whoops. That's going to be the actual list. That's indices. That's going to be a type of topology. So mesh topology dot quads. And then finally our submesh, which is nothing, which is just 0. We're not doing a submesh. All right, so for that, we've now created a mesh out of all this information, but now we need to associate it to the render texture itself. So let's do our, the mesh filter. So mesh, so temp filter dot mesh is going to be equal to our temp mesh. And there we are. We have kind of what we need. Now actually, our mesh renderer here right now is being created. I might want to generate that to make things easier for me. That is to assign a material to it and have everything work. So let's come over here to the game object, which I'm going to rename to something more meaningful, such as noise object. I'm going to add our mesh renderer. Really, you know what? Rather than generating the stuff at runtime, why don't we just create the mesh render and the mesh filter right here and right now? That's going to make things a little bit easier. And I'm just going to grab those and keep them for us to work with. So I'm going to do mesh renderer is equal to, or mesh renderer, and then let's do mesh filter. Make that lowercase. There we go. And then let's just do a get component. Instead. So there we go, and we'll get rid of this, and get rid of that, and we'll copy this, put that there, and copy this, and put that there. And then we're going to ignore a lot of what I just pasted, apparently. And let's see, that can go. There we are. And I'm still getting errors, so GameObject.getComponent, that needs to go. There we go. So now we've got that stuff, we grabbed it, we assign it, and everything's good to go. then we just need to, our mesh stuff doesn't make any sense anymore. So we just need to make sure we use the actual mesh filter now. And there we are. Now we can come over here and work with the material. So let's go ahead and create a material for this and call this camera noise as well. Keep them all the same name so we know they're all working together. I don't need to work with a standard shader, really. I mean, I guess we could and turn the emission up all the way, but that might, actually, let's do that. I have an idea. Let's put the camera noise into albedo, and let's also turn on emission and put the camera noise in color. So technically that should be fine. I'm gonna hit run really quick and just see if we get anything at the moment. So we get absolutely nothing. That always makes me feel good. Frame up, please. We have no mesh associated with it at the moment, but you know why? That's probably because we failed to attach the script to this object. So we need to attach camera noise. So let's do that. When in doubt, it's probably because you didn't attach your script. So let's do it. You do all that work and you forget to put it in the actual scene. So there it is. So it's flipped around. We're going to want to flip this thing around the other way. So what I'm going to want to do is actually invert the winding direction. So instead of facing outwards, I want it to face inwards. So the easiest way to do that is to change the indice order that I'm working with. So index, so we're going to go from 0 to 3 to 2 to 1 instead. And now it's flipped around. That has to do with something called winding order. You can look that up on your own. I'm not going to explain that right now. But basically, instead of the clockwise part of this thing that I was talking about before is really important in determining whether or not something is visible. That is, whether it's facing you or not. And by reversing that order and making it counterclockwise in this case, I'm making it visible from the negative Z direction. Otherwise, I would have had to have rotated the object around. Now I don't have to. It may cause other problems in the future, but for right now, it's going to work out just fine. Now, one issue we are running into is you can see that the texture itself is smaller than the visible range that I have here. So we're going to want to scale this thing up or bring it closer to the viewport. So let's turn this off really quick. And so where is it being created actually? So it's created right there. And that's the noise object. This is the noise object right there. So that's why. So I'm going to bring it forward a bit. Hit run again. And let's take a look at this camera. And we can still see that we have a problem. That's because it's 0, 0, 0. I'm going to scale this up inside. Wait a second. Why is that camera changing? It's frustum. Oh, that's based on, let's see, instead of free aspect, can we do, let's see. Can I change that to whatever the Vive happens to be? Is that the Vive? Trying to move it around to see if that's actually the Vive. There we go. That is the Vive. So that is the resolution of the Vive. So the problem is that it's still not big enough, so we are going to have to scale that up. So let's go ahead and do that. So grabbing this thing, what we're going to want to do is we can just do a multiplication factor, and I'm just going to make a new variable. Call this float scale factor is equal to, I don't know, 4.0f for the moment. And we'll multiply each of these by that scale factor, thus increasing how large it should be. All right. There's our scale factor. Now our scale factor you can see is way bigger than that. Now it's a little bit too big, so what I'm probably going to do is decrease that a little bit, maybe down to 3. And we'll see what happens now. That's much better, still kind of big. Once again, we didn't have to play with this. You can do some math if you want to, and you can figure out exactly how big it's supposed to be and stretch it exactly to the size of the object. I'm being lazy. Sometimes lazy is good. Okay, so that's good. And that's good as well. Very good. Okay. So we worked just fine there. What we will need to do is during the update function, we're going to want to take the mesh and update the UV coordinates and randomly kind of jostle them around the 0 to 1 range to make them appear like it's a noisy image where we're constantly getting different data points at each pixel. So let's do, I need to save the mesh first of all. That's going to make my life easier. Mesh, mesh. And then instead of temp mesh right here, let's do, get rid of U and put U in there. And then do U, U, and U, and then U. Great. Now an update, let's just make a new function called a private void update UVs. And this is going to jitter around the UVs of the mesh. So we're going to get a new set of UVs that are smaller than this set of UVs, and then offset them some set amount from, it doesn't really matter. Because we're using wrapping in this case, wrapping means that we'll come back around to the other side if we exceed it. So if this is our image right here, like we've used so far, and let me choose green. Down here is, where's my mouse? Is 0, down here is 1. If we wrap across this, we come back around to the other side, okay? So if our sampling is beyond this space, like it's here and here, it's going to, that is, if it goes beyond this area here, it comes back and wraps around to the other side. So we don't need to worry about things so much. Okay. And since this is a noisy pattern anyway, we also don't need to worry about seams or anything like that. So we'll take the UVs that we already have, and then we're just going to shrink them down a bit, because we're not going to use the entire texture. We're going to use just a portion of it, and then we're going to randomly jostle it some amount. So let's do, so actually I'm trying to think here. So these are the original UVs. So if we do mesh.UVs, we can do set UVs. We need to create a new list, or we can do just mesh.UVs, right? Yeah, UV. Now I believe we can create a new list directly from an old one. So if we do list vector2 temp is equal to a list of type vector2, and we do get UVs on this mesh dot get UVs. Let's get UVs return, what does that return us? Into channel, oh, it does return us a list. We pass in a list and it returns us the UVs. All right, so let's do that. So let's just create a new list is equal to a new list of type vector2 and call this nothing. There we go. So we got our new UVs back. Actually, I want to save this UV set as our base UV set that we continue to work with forever. I don't ever want to not be working with this UV set. So I'm going to move this out, because once we create it, I want to keep it. So let's do this part here. We're going to move up over here, and then instead of declaring it here, we're just going to set its values. And now we can continue to reuse this throughout everything. And then what I want to do is create a new list, and I'm going to pass in those UVs. And I believe that's a constructor, right? We can take in a collection and work with it. So now that we have this list, okay, so now I've got these UVs stored up. We can manipulate them, so we need to have a random value that we're offsetting it by. So let's do, and that value is X and Y. So we'll do a, random dot, let's see, inside unit circle, I guess. that returns a vector 2, which is exactly what we need. So let's do vector 2 offset is equal to this. And now we just need to iterate over each element in the list and offset, scale them down and offset them, basically. So let's do for each var, what is this? I in temp. I hate that notation. I want to call it vector 2 in temp. These are UVs. I don't like that naming. If we're going to make that easier on us. And then I'm going to do vector 2 is equal to vector 2 plus the offset amount. And the offset amount is inside of unit circle, so it should be positive or negative. So what are you giving me problems for? Oh, I can't change it because it's a for each. All right, fine. That's why I hate for eaches. So for int I is equal to 0. I is less than temp UVs dot length dot count. What is it? I plus plus. And we do all this nonsense. And we do. That was a problem there, wasn't it? I wasn't doing the right thing. So temp UVs. I had written the wrong thing down, and I'm an idiot. But anyway, this is the same thing. It works just fine. So we're taking it, we're adding its offset. We also do want to do a scale, though. So I'm going to do... So we're getting a value inside of a unit circle. So that's going to be, you know... how much do we want to scale this down? I don't really know. It's up to us. Let's just make a scale factor. Float scale factor. So what the scale factor is going to do is, let's factor it down by not half, but maybe a quarter maybe, and see what that looks like. So it's going to take the coordinates here that we have. Let's do purple. And instead of it being all the way big like this, it's going to shrink it down to something smaller like this for a quarter of it. And then we're going to be shuffling it around randomly throughout this entire area. And the value we use is going to be between +1 and -1, or +0.5 and -0.5. I can't remember with inside unit circle what that, with radius 1. So yeah, so the radius is 1, so it's going to be probably -0.5 and +1.5. So we're going to be kind of zooming all around the whole territory, because if we wrap back around, we come back on the other side. Hopefully that makes sense. So anyway, updating UVs, we're good there. And then all we need to do now is do mesh.UVs or set UVs, whatever we want to do. And then we can do, let's see, temp UVs. And I think it wants a channel. Our channel is the first one. So that's all we need to do, 0. And we should be good to go. We'll do update UVs inside of update for right now. I don't know if I need to do it that many times, but it's a good place to start. And all right, so now we're going to turn that off, and we're going to go to the noise object and set its material to our camera noise material. I'm going to hit run and see what actually happens. So there's our, holy boy, that's our noise. That is very noisy. So I would call that a pretty good success. So if we were looking through the camera, this is our preview. Now the noise might be too small to notice. I don't know, it's hard to tell from there. Can I, let's see. But I think that's a pretty good job. So now that we have that, we can go into our camera code and add it to work. So here's our camera noise stuff. I'm going to add another variable. So here's delay, and that's how long it took to switch between them. So what I'm thinking is during that delay time is the time that we're going to be on the camera noise. So moving down, we should have our decrement and increment camera stuff, which is right here and on the other one. So really what I probably want is some eye enumeration. So actually, let's see. So decrement camera, I think I want an eye enumeration that will move us, wait till that amount of time has passed, and then change the camera for us. So let's do eye enumerator. What do we want to call this? Coroutine, increment camera. And I'm going to do the same thing for decrementing the camera as well. Decrement. And then the first thing we're going to want to do is switch our camera. So we're enabling those different cameras here, whichever one we happen to be on. So we'll do current, let's see, actually, let's grab the code from in here and bring it in from the last video into there. Same thing with this here. What we're going to do is get rid of the code in here, and then this code is going to be responsible for starting the coroutine that we're going to be working with. So let's go ahead and do start coroutine. Grab that, copy and paste that there, and we'll do this coroutine here, and we'll do this coroutine here in decrement camera. Now that we have them both working, this is giving us some problems. It's saying, hey, you need to set stuff up. So first of all, we say busy is equal to true, cameras.current enabled equal to false. So we've disabled the current one. We increment the current camera, but what we want to do is actually enable the, so we want, what is it? Noise, camera noise dot enabled is equal to be true. Then we increment the camera. We're going to wait the amount of time that we need to wait. So let's do a yield return new wait 4 seconds, and that's going to be equal to the delay time that we're working with. And then after that, or actually before that maybe, we'll do this, which is where well, it doesn't matter. We check to see whether or not we've gone too far. We'll do that before it, just to keep everything together. Whoops, I grabbed the wrong stuff. There we go. We check to make sure that we haven't exceeded our bounds. If we haven't exceeded our bounds, we're good. We wait the amount of time we're supposed to wait, and then we're going to turn off the noise camera. And then we're going to turn on the camera we should actually be working with, okay? So now let's apply this logic down here. We're going to grab the noise camera, just like before. And we're also going to disable the prior camera. So busy is equal to true. And then we want to do this. So cameras.currentCamera.enabled is equal to false. Camera noise.enabled is equal to true. We decrement the camera. We check to see whether or not we're still within bounds. And if we are, we're going to then wait our delay amount of time. And then we are going to go here to our camera noise.enabled. We're going to turn that off. And then we're going to turn the camera we're actually on to true. Save. Great. Okay, so let's go ahead, and I don't know if I can test this. Let me see if I have everything I need. Turning on controllers now. All right, let's go ahead, hit run, and see if we have any success. So there's run. Whoa. So let's think about this for a second. What just happened? So I'm guessing camera noise. We need to turn camera noise off at the beginning. That's probably the issue. Actually, not the whole thing, just the camera part. Now it should work. Or not. Hold on a second. That's camera noise. The camera itself is off at this point. If I hit run, why am I getting a camera? Oh, I'm not. That's just my scene view. Okay, whoops. Excuse me. Okay, I'm gonna throw this on my head now. Back up a little bit here. And there's my tablet. Let's see, I am not able to change scenes with my tablet though, so something's going wrong there. Whoops, so let's check it out. Do I have any errors? Yes, unassigned reference exception. Tablet camera manager has not been assigned. You probably need to assign a reference. So let's figure out what that is. So camera noise, so the camera noise reference I didn't add. So going to camera manager. There it is up there. Yeah, stupid me. Hit that. Hit run now. Let's see what happens. Okay. And really, there's no reason for that to be updating while I'm not using it. So I can fix that if I want to. So switching hands really fast. Let's go ahead and update. Whoa. Huh. So what I want to do is not do that. I want to change the texture that I'm rendering to. So I gotta, but that's kind of cool. Not what I wanted, but cool nonetheless. I really wasn't thinking when I did that, was I? Okay, so let's see what is happening here. We are doing cameras.currentCamera.enable is equal to false. And then camera noise.enable is equal to true. And are these cameras... Yeah, all these cameras have the target texture set. This one doesn't. That's the problem. So let's do tablet for that. Save that really quick, run it again, and see what happens. All right, so we're in here, backing up. There's my hand. And it's drifting a bit because I don't have good tracking at the moment. But we can clearly see there's the static as we move from scene to scene. Not much to see in some cases, but there we go. We got it working. So great. And see, it is illuminating as well. Let me see, actually. If we use some of the post-processing effects, that illumination will actually blow out and look pretty cool. We can take a look at that later on. But anyway, that's it for this video. Hope you enjoyed it. Relatively simple thing to implement and to put into the game, but it ended up taking a little longer than I expected. Anyway, check back next week when I'll show you something new. I don't know what that is yet. I'll have to figure it out. So long, everyone. Have a great day, night, or wherever it is, whatever it happens to be. And I'll see you later. Bye.